When being asked to solve an absolute value equation, we begin by recalling our definition. If the absolute value of A is a quantity B, then either A equals B or A equals negative B. That's based on the fact that we think of absolute value as distance on a number line in either direction. We begin then with a step 0 by observing that the absolute value must be isolated on one side of the equal sign. So we look at example 3, and we notice that that is how it already starts. The absolute value of 2x minus 3 is supposed to be 17. Then we realize that we need to consider two cases. Case 1 is the positive thought that the amount A is equal to the positive value of 17. Case 2 then will always be the situation that it is equal to the negative of 17. It is a good habit to set up both of these cases before we start solving either one so that we don't forget that there is in fact a second case. We continue in our usual way of using algebra rules to solve in the first case, believing that x could equal 10. In the second case, we proceed the same way. We add 3 to each side, noting that a negative 17 plus 3 would create a negative 14, leaving 2x to equal that, and the resulting x equals negative 7. After solving both cases, we then return to our procedure and notice that there is a step 2. It's really important to check using the original equation. So substituting in for the first case, we would find that the absolute value of 2 times 10 minus 3, does that in fact equal 17? In like fashion, the second 2 times negative 7 minus 3, does that in fact equal 17? Well, 2 times 10 is 20 minus 3. The absolute value of a positive 17 is in fact 17, so that solution x equals 10 checks. Now in the second case, we take 2 times negative 7, so we have negative 14 minus 3. That would be negative 17. Taking the absolute value of negative 17, will that result in a positive 17? The absolute value of a negative is in fact positive, so in the second case we also have a check. We therefore have, in this case, two different solutions for the value x, 10 or negative 7. Continuing with the second example, we notice this features a case where the absolute value has other terms on the same side. So we must go step 0 and isolate it by adding a 5 to each side. Notice we then set up our case 1 equaling the positive 5 or our case 2 equaling the negative 5. Arriving at two potential solutions, 9 and negative 1, we go to our step 2 and check them. Substituting in, 9 minus 4 is 5, absolute value 5. Minus 5 is 0, so 9 checks. Negative 4 minus 1 is absolute value of negative 5. We know that to be a positive 5 minus the 5 that's there, and we have another check. We have two solutions to this problem. We'll now consider number 5 underlined. And again, we notice it's a situation where we need to begin by isolating the absolute value. As we subtract 16 from each side, we have the resulting absolute value of 5b plus 9 equals negative 14. Now we return to our definition, and the detail that I hadn't written the first time is that this is the definition and b must be positive. Well, this situation here results in a b that is not positive. Therefore, just upon inspection, we know that it would have to be the case that it is the absolute, no solution to this absolute value. Now, consider that we went forward and solved. What would happen? Well, we arrive at an answer of negative 23/5. We notice that when we substitute it back in, it will in fact result in a false statement.